Welcome to Escape Velocity Space News. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. I'm writing and recording this on November 14th. It is now 9 days after the U.S. elections, and we now know the Republicans will control all three branches of the U.S. government. Historically, Republican-controlled administrations have been good for science and have pushed to see big things accomplished. This year, things are more unclear. The president-elect is creating a new Department of Governmental Efficiency led by Elon Musk and Vivek Ramaswamy, with Musk calling to cut $2 trillion, or roughly 30%, from the U.S. federal budget. We have already discussed the devastation the 2023 Fiscal Responsibility Act caused to NASA and the National Science Foundation science budgets, and that act only called for a 3% cut to the federal government. If the 30% cuts are distributed uniformly, I foresee research institutes that are funded by federal grants either dying or needing to transform into something radically different. If, as may be the case, entire segments of the government are cut, NASA and the National Science Foundation may remain safe, but at a cost I'm not sure I want to see society pay. We are seeing schools get notices to expect the Department of Education to be defunded. And if the Department of Education goes away, it is unclear what will happen to programs such as federal student loans and Perkins grants for college, to the federal school lunch program, and to the federal funds that support schools in impoverished areas where property taxes can't provide the same kind of education wealthy communities can easily afford. In the long term, getting rid of the Department of Education will be far more devastating to science than cutting funds for existing scientists to maintain their programs. If I sound a bit dark, it's because yesterday the Jet Propulsion Lab laid off 325 employees, including many scientists and engineers I know and have worked with for years. This is JPL's second major layoff, and it comes in the face of not seeing NASA and thus JPL receive the funding needed to maintain current programs. If you have ever attended a museum event or local astronomy event with volunteers from NASA, you probably were learning from NASA Solar System ambassadors, and some of you may have been NASA Solar System ambassadors. That program is now dead. I'm still not sure what else has been canceled, but this is only the beginning. The number of astronomers and planetary scientists in the U.S. is measured in the thousands. And these cuts mean every one of us has friends out of work and looking to reinvent themselves in fields other than science. This is where we are, and seeing what is happening now and what could be coming in the near future has all of us experiencing sleepless nights. But those of us who are still here will keep working and keep looking for ways to extend what we know about our universe. We will keep applying for grants and looking for ways to stretch every dollar we have absolutely as far as possible. And here at EVSN, we will share the science that is resulting from this work. And that science is full of fire and ice. So that will be our theme for the week as we discuss volcanoes near, far, and around other stars, look at ice across time and space, and more. We also have updates on rocket companies breaking federal regulations and tales from the launch pad. All this and more is coming to you right here, right now, on EVSN, a product of CosmoQuest, and supported through our Patreon. Let's start our fire and ice science by looking at a world 635 light years away that just might have a fiery moon of volcanic goodness. To be honest, every aspect of this system is hot. The star is similar to our sun, but the planet is on a 2.8-day orbit around that star. And this orbit makes Mercury look super distant from the sun. From our perspective here on Earth, this world, WASP 49a, passes in front of its star, allowing us to see its size and the chemical makeup of its atmosphere. Observations show the planet to be extremely overheated and a sibling to Saturn. While observing this world, astronomers discovered a cloud of sodium displaced from the planet's location. This cloud appears to be in motion and, per the paper, can't be readily explained by stellar activity, star spots, tellurics, or the interstellar medium. When all mundane reasons can be ruled out, it's time to look for extraordinary explanations. In this case, the observed gas is consistent with this hot Saturn being orbited by a volcanically active rocky moon. Now, as Carl Sagan has said, extraordinary claims require extraordinary evidence, and a lot more data is needed before we can say this absolutely is what's happening. For now, though, this is a cool possibility that totally fits the data, and I, for one, wish this team all the telescope time they might need to prove this super cool result. Or should I say, hot result. Jupiter's moon Io is the most volcanic object in our solar system today. But our planet gave Io a run for its money more than 200 million years ago. At that point in our planet's history, our world was dominated by the Triassic period's great reptiles, amphibians, and earliest dinosaurs. This was a time when the Earth had a single continent, Pangaea, and life was wildly evolving. But the breakup of Pangaea into the continents we see today was one of violence and mass extinction. It has long been known that the Triassic-Jurassic boundary marks a great extinction and a period of massive volcanic eruptions that are linked to the continents splitting apart. From earlier research, we thought this volcanism may have spanned long periods of time and resulted in the Earth getting too hot to support life due to carbon dioxide-related global warming. New research appearing in the proceedings at the National Academy of Sciences and led by Dennis Kent finds that the continent-rending volcanic upheavals likely occurred over very brief periods, lasting less than a century each. These events released so much sunlight-reflecting sulfate particles into the atmosphere that our planet underwent a massive cooling. Basically, if the sunlight can't reach the surface of our world, the world grows cold. And a cold Earth was not a good place for cold-blooded reptiles. But it did lead to the age of the dinosaurs. This research finds that the small feathered dinosaurs survived and went on to get much larger. Smaller turtles, lizards, and mammals also made it through, potentially because they could burrow to escape the cold. What I love about this story is how much our understanding of dinosaurs has changed since I was a 5-year-old who could identify every skeleton in the museum. We now know these great beasts evolved into birds, were warm-blooded, and in some cases tended their eggs and possibly their young. And they were warm-blooded, and that let them survive the volcanoes making the world cold. Unfortunately, when that asteroid later struck the Yucatan Peninsula at the Cretaceous period boundary, everything on the surface that wasn't washed away in tsunamis was baked by the planet's superheated air. For dinosaurs, at least, fire and ice are not equally nice. After a break, we're going to continue our explorations of fire and ice. Stay tuned. Volcanoes have played a role in mass extinctions at multiple times in our planet's geologic history. Exactly how they kill off everything is dependent on the rapidity with which they erupt. If the eruptions are brief, sulfates and other particles will fill the atmosphere and reflect sunlight, causing more cooling. If instead things occur over long periods of time, particles won't build up in sufficient numbers to cool us off, while the release of carbon dioxide will lead to greenhouse gas-related heating. If that is confusing, all you need to know is massive short-lived eruptions make for a cold world, and slow, long-lived eruptions make for a hot planet. And slow carbon dioxide releasing eruptions are just what happened at the end of the Permian Age 252 million years ago. If you want to scare yourself, Google the Siberian traps. Essentially, a massive swath of Siberia became a massive volcano for a while. And this wasn't just casual eruptions. Enough lava was emitted that it could have covered the continental U.S. in half a kilometer of lava. And if that's not bad enough, even when the volcanoes had stopped emitting lava, they continued to emit carbon dioxide, perhaps for millions of years. New research shows how this happened with the end Permian extinction event, and perhaps also at other times in Earth's history where periods of warming couldn't be easily explained. In addition to explaining mass die-offs, these results also show that our planet can bounce back from warming periods triggered by the release of carbon dioxide. This work appears in Nature Geosciences and is led by Benjamin Black. According to Black, quote, "Our findings are important because they identify a hidden source of CO2 to the atmosphere during moments in Earth's past when climate has warmed abruptly and stayed warm much longer than we expected. We think we have figured out an important piece of the puzzle for how Earth's climate was disrupted, and perhaps just as importantly, how it recovered. If this is true, it could be good news for Earth's recovery after human-driven climate warming. It means that if we stop turning the thermostat up on geologic timescales of hundreds of thousands to millions of years, climate can recover." So, how about we turn down the CO2 and run the experiment to see just how long it takes our world to return to normal? Our planet has been driven to environmental extremes at many times in its history, and many plants and animals, including humans, have demonstrated they can survive less than ideal conditions. The last major ice age hit its peak 20 to 26,000 years ago and allowed humans to cross icy bridges between continents. That ice age, however, didn't encompass the entire planet. Our world hasn't been a complete snowball since before the ages of reptiles and dinosaurs. In fact, the last global ice age took place 635 million to 650 million years ago. And when a planet goes from entirely covered in snow and ice to not entirely frozen, it gets really gross for a while. New research appearing in Proceedings of the National Academies of Science and led by Tian Gan uses lithium isotopes to identify just when our world became a slushy mess. Essentially, the early Earth, when our world only had microscopic life, went through a period of extremely low carbon dioxide levels, and this led to our world freezing. This also led to super salty water beneath a deep layer of ice. Volcanism, however, slowly released carbon dioxide into the atmosphere until one geologic epoch. The amount of greenhouse heating from that carbon dioxide was sufficient to start melting the ice. This led to fresh water from melt pooling on the surface of the super salty oceans. This difference in chemistry led to differences in the chemical composition of the rocks that formed in different places. A chemical difference, Gan's paper documents. Our Earth is currently working its way toward being the exact opposite of a snowball Earth, as we see glaciers and ice caps receding across the planet. This is fundamentally changing our landscape and how we as humans interact with that landscape. These changes are most evident in the northern Arctic landscapes of Alaska, Scandinavia, and Siberia, where indigenous peoples have lived in close contact with the land and rely on permafrost for refrigeration and frozen waterways for transit. As permafrost melts, weird stuff is happening. From amazing frozen animals being revealed to giant sinkholes, it's hard to know what each day is going to reveal. While we expected the animals, we didn't expect the sinkholes, and we didn't account for the massive amounts of greenhouse gases being released. Specifically, the potent greenhouse gas methane is being released. This work is published in the Journal of Global Biogeochemical Cycles and led by G. Hugelius. According to team researcher Abhesik Hatterjee, quote, "We know that the permafrost region has captured and stored carbon for tens of thousands of years. But what we are finding now is that climate-driven changes are tipping the balance toward permafrost being a net source of greenhouse gases." End quote. In the past, permafrost trapped dead plants and animal matter in the ices, locking away their carbon for up to hundreds of thousands of years. As the ice melts, this material decays and releases greenhouse gases, including the carbon-based methane molecule. Temperatures in the Arctic are rising 2 to 4 times faster than global averages. It is possible that we are going to see a feedback cycle where over the next 20 years the release of gases in the Arctic regions will drive increasing temperatures, coupled with the melt of permafrost or other carbon gas releasing problems like wildfires, because sometimes fire and melting ice like to work together, apparently. Over the next 100 years, things should reach equilibrium again, with the region being roughly balanced between emitting and absorbing greenhouse gases. But hey, while the world melts, at least we get more woolly mammoths to study. I, for one, would be okay with more woolly rhinoceroses and cave lions to see in museums. Up next, we look at the world of aerospace and all the ways things are leaving our world, or at least preparing to leave our planet. Stay tuned. I'd like to add to our rocket coverage the latest case of a rocket company failing to get complete approvals prior to firing things off. In this case, we would like to call out Blue Origin for their use of a deluge system in Florida during testing of the New Glenn rocket, which we hope to see launch later this month. On October 31st, after we recorded our last episode, the Florida Department of Environmental Protection released a letter warning Blue Origin that they had used their water deluge system without proper permits. They had applied for permits on May 31st. Per this letter, quote, "The static fire appears to constitute an intentional unauthorized discharge of untreated industrial wastewater to the environment," end quote. In this case, the wastewater was released into a holding area rather than discharged into the landscape. We're not entirely sure why breaking the Clean Water Act is the trendy new thing to do in aerospace, and we're keeping our eyes open to see what happens to the EPA and FAA under the new administration. Vivek Ramaswamy has said he and Elon Musk will slash and burn federal agencies. As a presidential candidate, Ramaswamy promised to eliminate 75% of the federal workforce. We don't know what this will mean other than higher unemployment rates. But there is reason to suspect corporations will face fewer regulations and permitting requirements in the future. For now, we wait and see. When we know more, we'll bring it to you here on EVSN. Next up, I'm pleased to welcome on aerospace correspondent Erik Madaus for this week's Tales from the Launchpad. Hey, Erik.
On November 4th, Russia launched the Cosmos 2579 mission from the Bluz Cosmodrome in northern Russia. Let's watch the launch. Cosmos is the general designation for a huge variety of Russian military spacecraft. This one is thought to be an optical imaging satellite called Bars-M, and is the last of 4. Also on November 4th, Japan launched the Kirameki-3 satellite on an H3 rocket. Let's watch the launch.
全システム発射準備完了
All systems are go.
メインエンジンスタート
Main engines start.
SRB3 点火リフトオフ
Three boosters ignition and lift off.
H3 ロケット4号機は2024年11月4日午後3時48分00秒に種子島宇宙センターから打ち上げられました。
The launch took place from the Tanegashima spaceport in southern Japan. Kirameki is a series of communication satellites for the Japanese military. The variant of the H-3 that launched Kirmeki 3 was the 2-2 variant, with 2 engines on the first stage and 2 solid rocket boosters. It's available with up to 3 engines and 4 solid rocket boosters, or no solid rocket boosters at all. All H-3 launches so far have been the 2-2 variant. On November 4th, Russia launched the Iosphere M1 and 2 satellites from the Vostochny Cosmodrome in eastern Russia. Let's watch the launch.
Предварительная. Промежуточная. Главное. Подъем. Прошел контакт подъема. Двигатели центрального и боковых блоков вышли на режим класса ступени. 10 секунд. Параметры системы управления ракеты-носителя в норме. 20 секунд. Двигатели первой и второй ступени работают нормально.
Iosphere M is a new constellation of satellites operated by Roscosmos, which will observe the Earth's ionosphere. 2 more will be launched on future missions. The Soyuz rocket also carried 53 small satellites from a variety of countries. I don't know if it was a competition or something among the various orbital rocket launching organizations, but SpaceX wasn't going to be left out. They also launched something on October 4th, CRS-31. CRS-31 carried 2,841 kilograms of supplies to the ISS, docking on November 5th. New this mission would be a demonstration of the Cargo Dragon's ability to reboost the ISS, something previously done only by the Russian Progress vehicle and Northrop Grumman Cygnus. The demonstration was successfully carried out on November 8th, boosting the ISS's altitude by about 1,100 meters. On November 5th, Rocket Lab launched the Changes in Latitude, Changes in Attitudes mission from their New Zealand spaceport. Let's watch the launch.
5, 4, 3, 2, 1.
The mission was procured by an undisclosed commercial customer, and no details about the payload were disclosed. Rocket Lab reported that the mission contract was signed less than 2 months before launch, a record for them. On November 8th, China launched 4 commercial SAR satellites on a Long March 4C from the Jiuquan spaceport. The 4 smallsats will be for the PiSat constellation and were built by Shanghai Aerospace Technology Corporation, a state-owned satellite manufacturer. I wanted an excuse to put this mission patch in the episode, since it's neat, and the launch segments typically only have the launch image. This is the patch for the PiSat 2 mission from China. It has the rocket on the background of red, orange, and green shapes, like a radar image, with stars above and the location of launch site on the right. We keep track of orbital launches by launch site, also called spaceport. According to RocketLaunch.live, so far this year, the United States has had 116 launches, China has had 53 launches, New Zealand has had 11 launches, Russia has had 7 launches, Japan and Kazakhstan each have had 6 launches, India and Iran each have had 3, French Guiana has had 2 launches, and North Korea has had 1 launch. This makes the total number of launches so far this year 208. Finally, there are 9 total in space. Of these 208 launches, there have been 4 failures, reminding us that space is hard.
Thanks, Erik. Before we go, I have bad news for one of statistics' favorite sayings. As the story goes, given enough time and enough monkeys randomly pressing keys on keyboards, the complete works of Shakespeare will eventually get typed out purely by chance. This is called the infinite monkey theorem. The only problem is, according to work by Stephen Woodcock and Jay Falenta, our universe won't last long enough for this to happen, given just one monkey. And when they increase the count to equal the number of chimps, which are not monkeys, they found that 200,000 chimpanzees typing on keyboards with only 30 keys at a rate of 1 key press a second, these chimps would not be able to accomplish the task either. Although any given chimp or monkey had a 5% chance of randomly typing bananas in their own lifetime. So, I guess we should all be glad of the primates who are capable of writing and typing in non-random ways. This is your reminder, there are amazing books out there. Pick one up and take yourself to another world. No monkeys or apes required. And that is it for now. Good night, everyone, and remember to go out and look up. Oh, and please give this video a like and subscribe so the algorithm tells you and the world when new science is ready to be learned.